Hello everyone, please welcome Emil.
So hello there. Yeah, this workshop, or it's kind of more of a talk now, but I'm going to try to keep it like a bit interactive with all of you. It's about r2wars, and we'll get into what all of that is fairly quickly. This is all supposed to be a workshop. I've held this workshop a few times here and there, and I've got a few slides also just bringing the brief topic to you. But in the end, it's interactive. So the best thing is if you just take out a laptop and then just start hacking on it, because in my opinion, the best thing in order to learn how this all works is just to do it yourself. So I'm going to give you a brief introduction, and then we can maybe form a small few groups and so on, and well, try it out. But first of all, what is this actually? So r2wars, BattleBots in shared memory, catchy name, whatever, you'll see it's a bit abstract, but in the end it's pretty much that. We are trying to battle some bots, but in a bit more, well, low-level way. So first of all, R2. What's that R2? And everything I'm going to say here is kind of written down in that blog post there. And if you can't really follow with all of that, just read the blog post and ask me questions or so. Everything is there. So you can take pictures of that, just write down the link or so. Just go on emil.space, just click yourself through. Everything is there because I want you all to have fun with all of this. So yeah, you should be able to follow along. The top thing is the blog post I wrote, and well, the main page for BalCon, there's the blog post I wrote 2020 or so, which pretty much started all of this because I wanted to look into all of this and was like, well, this is all kind of complicated. Let's break it down a bit. The bottom one is my implementation of all of this, and you'll understand what this is fairly quickly. So yeah, let's go on. Radar. So r2wars starts with r2. r2 is short for radar2, and like many things, you kind of have to like get a lot into what this actually is in order to have like a lot of fun with this, and that's why we're doing all of this. So in order to use radar, we can use r2. r2 is just this small like tool which Pancake, he's called, or that's his nick, started building like 20 years ago, and it does literally everything by now. The thing is, it's not like a nice fancy tool where you can just click around and do stuff, but if you, for example, open radar with 2 minuses, so don't open a file, it just gives you this prompt. And that's kind of like, it doesn't help you much, right? So you have to know what you can type in there in order for it to actually help you. And we're going to use this tool like quite a bit now because everything is based upon that tool, but I'd love to give you a short introduction into like what this is and how you can get help and how you can actually work with it. So yeah, the main feature in radar, like in order to get help, is the question mark. You've probably seen it from time to time. It's this fancy little symbol there, and by entering a question mark you can get like a lot of help. So for example, I've just entered a question mark and it gave me like a big dump of all kinds of first level commands. So everything is built upon these small commands. A command mostly consists of a single character. For example, we've got the character A here, which stands for analysis command. So for example, let's analyze something more. Then we'd say A question mark and we get more information on the A command. For example, there's AA, which analyzes all, or AB, which analyzes bytes, and so on. So all commands are built up that way. You just have to chain like all small characters with each other, and in the end you get like a fancy thing, AODA, whatever, which for example gives you like every single instruction that can be executed and a short description on what that actually is. So yeah, AODA, those are all kind of weird, right? So there's this one small trick here, that's what I included here, is the question mark star tilde ... And in the beginning I was sitting in front of radar and was always like, I pretty much know what I want to do, but I don't know the command, and finding the commands isn't always that easy. So in a lot of cases you'll probably, when playing around with radar wars afterwards, want to enter the question mark star, which literally prints out every single command there is. It just tells, hey, everything. There are now, oh wow, over the 3,000 commands by now, so that's a lot. And normally you can say grep, I don't know, analysis, that just grabs for analysis, but you'll often come by that you grab for something, then remove it, then grab for move, then grab for something else. The radar people were so nice to include the tilde character, which is pretty much a pipe grab, which allows you to search through all of things. So again, you can say question mark, star, tilde, for example, print. Then you get all the print commands, and then you can see we can print 1 byte of memory with PV1, and so on. But say you want to search for everything and not just grep all the time, then you can enter dot, 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 which is kind of a weird command, but it gives you like an interactive like prompt where you can say, hey, I want to print stuff and in hex, and then you can see all commands that print in hex, and you can interactively search for all of this. So yeah, that's radar, and radar can do like an awful lot of stuff, and yeah, I think we're going to just skip that because we just want to get actually into like what we're supposed to do, namely play radar 2, r2 wars. So yeah, then what? Like, what's that to do with all of this? So in most small disassemblers and everything, you've just got the small disassembler, and then you've got another tool doing stuff. Radar is like a weird tool which does pretty much everything you could evenly think of. Like, I don't know why, but they just crammed it all into there. And it's actually quite fun because from time to time you realize I can do literally everything in radar. That doesn't mean you should do it, but you can. And one of those things is, for example, analysis of stuff. And you don't want to write a new analysis path for everything because, for example, you've got like x86 binaries, which are nice, and then you can write an analysis stuff for that, but then you might have some Game Boy cartridge or so in another instruction language and so on. And that's just a lot. So people were like, hey, let's build an intermediate language, and EASL is the evaluatable string intermediate language of radar. To be honest, like, you don't really have to care about all of that because, well, in the end, this is just the intermediate language which is used, so we can just do analysis, execute stuff. So what happens is, if we've got a normal binary, we can load it into radar, and with that we can tell radar, hey, could you please show me the EASL of all of that, so the intermediate language, and using that it can actually start executing things and do simple analysis. In the end, you'll probably never see it because it's kind of hidden in the background, but yeah, it's just nice to know that the thing is there. And well, I don't have many slides because we want to do this practically, but what is then radar wars? So maybe some of you have heard of Core Wars, which was like a game people built like years ago, and radar wars is kind of like that. Using this EASL, we can actually, in radar, create a small VM, create a small stack, and just execute a binary or, well, a small program we throw into there. And using all of that information, we can do like weird stuff. So people were like, okay, wait, we can execute some kind of small function, binary, whatever we throw into there, just inspect how it's working. And we could do that with something else as well. So we can just create some kind of memory space, and then load our binary into there, then just execute the individual instructions using the EASL intermediate language. And then people were like, wait, we can do that with one binary, but what happens if we place another binary there and then just swap that out? So what r2 wars actually is executing two binaries in the same memory space at the same time, and the war part comes from they try to overwrite each other. So if you provide some kind of small binary, which we call just a bot in the radar wars world, into the memory, the bot would try to actually override the other bot. So the other bot executes some kind of instruction that is invalid. Now that's a lot of talking for yeah, small stuff. What we can do is just look at it. So I've been doing this for a few times now, and this is actually how it looks like, and there's one bug in here, which I can explain shortly. But what you're currently seeing here is 1024 bytes of memory, in which at the small part, I can just pause it here, there's a bot in here. So it's just placed in here, some small instructions, and there is apparently another bot up here, but it's not there because radar has got a lot of bugs, and it's horrible because the bot wanted to be like built, but wasn't able to be built, so it just returned a lot of zeros, and now you see all those zeros. So the whole point of radar wars is to, well, provide bots which override each other, and you can actually do that. So if we look into how it works, So let's recap this a bit. In the beginning, I was sitting there and was like, okay, I'd love to play around with r2wars, and how this all works. But I found it quite intimidating to look into the whole source code, because like people build like a giant implementation of all of this with all kinds of edge cases and so on. And I was like, well, I want to understand how this works, so I literally just built this myself. And it's not long. It's 400 lines long. It grew quite a bit, but it's mostly built up of small components you can easily understand. So if you just go into that Git repo, just open the file, don't be intimidated, look into it, you probably understand what is going on. There are a few small code blocks which look, for example, like this, in which I, for example, just open a Radar pipe. You might ask yourself, what's that? So Radar, this small command line tool and everything, people use it for all kinds of stuff, and they also want to automate it. So they built Radar pipe which allows literally, I think there are like over 20 or 30 programming languages which have Radar pipe bindings by now, but they all allow you to interact with Radar over some kind of program. So instead of like just entering Radar commands all day long by hand, you can actually automate all that stuff. And that's actually what's happening in r2wars. So for example, here we're building a bot. We are just opening Radar without anything, so this is --. And then we're executing the rsm2 command, which is a subcommand in Radar, which allows us to, for example, build this current bot with the given architecture, the amount of bits, and, well, the path to the bot itself. So that's all nice, but how does the actual emulation work, right? So looking into the code and all of that right now, but there's one slide here which I can show you in big, and that is pretty much everything that is happening. And that might look like completely weird because like, what is going on? But it's actually not that crazy. You just have to like take the individual commands, all the individual characters, put a question mark behind it, and then you get like a lot of information what all this is. For example, the first command, AEI, is analysis, easel, and then I is initialize the VM. It's horrible, I know. Radar has been like one of the programs where I think like it's a lot of fun to play around with if you know what you're doing. If you don't know what you're doing, it's really hard to get into it. And that's the point of all of this. So you've actually got a project or so which you can actually play around with this. So that's pretty much how I learned like playing around with Radar, just taking project, taking binary, just playing around with it all the day, and then yeah, that goes on. So the first command we've got here is AEI, which is, well, the command you can use in order to initialize the VM. The second one is for initializing the stack afterwards. And then we've got WX, which writes the hex bytes, which are then coming, and then at a specific address. So what this is doing, it's literally taking our small binary, which we, or a small bot, which we built, and writing it into the memory. Then we set the program counter with AER, which is analysis, easel, registers, PC, program counter, to the address of that bot. Then we set we increased the stack pointer just by a bit, so that bot actually has a bit of stack space. And then we can step. And step just means, hey, you've got the program counter at the beginning, step 1 instruction, execute what is actually there. And yeah, then we've executed a single instruction. Now, when executing two programs in the same memory space, this is all like super abstract and actually super simplified and everything, but what we are doing here with the RERR command, which is horrible, I hate these commands, but we are storing the registers from the bot. So we can look into this. If we RERR command, that command actually gives us an output, and with RER, like this, we can get a list of every single register which is currently in use. Like this easel intermediate language has got the registers x1 to x30 and then a few special registers down here, and they are literally completely empty currently. But what RERR actually does, it's kind of fun, is it gives us like the Radar commands to actually set those registers. So if we actually set those registers to specific values, because our small bot, for example, set the value of a specific register to a value, using the RERR command, we can just get the actual commands in order to use that again. So yeah, using that, we can actually, I'll just zoom into here a bit. Using the valor command here, we can actually store the register state. Then we can probably store the stack state. I'm actually not doing that in my current implementation because I was playing around with that. But using all that, we can then swap in the other one. So we can completely clear it and swap in the other one. And now we get into like super weird state in which we've got like a bit of memory where our two bots are inside, and we share some memory, for example the memory where they live in, but we don't share the registers because they want to execute individually. And now we can do like super weird stuff, for example what we could actually do is execute like two bots from different architectures and two different builds and everything just completely mismatched together. So we've got like an x86 bot that might be able to just be executed in the same memory space as an ARM bot. And that sounds like completely crazy, it actually is, but it's possible, and that I found like quite interesting because like why would you even do that? But you can play around with that and just, well, try it out. Yeah, so the next slide here is literally that. You can just clone that repo, go into the repo, and you have to disable Cgo. I don't know why, because like some kind of bug was introduced in the last year and a half or so, which just, I have to do it. I don't know why it's not working elsewise. I'd have to do a deep dive, but yeah, that's literally how you can execute this. And I also built like a small timer in here, so between every round there's like a single second which is where it pauses. If we just go here and set the, whoops, I don't want to insert smileys. We can, for example, just set this timer to 0.1 second and actually see, well, that executes fairly fast and just you don't see anything. You could also look into like how you can visualize this, because this is like 1024 bytes of memory. That's actually fairly simple to visualize. You could play around with everything in there. Just open, make the arena bigger, and literally, if we just, whoops, I think where did I define that? Size? Yeah, max programmer size. So there are a few flags you can provide to this binary in order to, for example, set the architecture of the both bots or set the maximum size of the bots you can insert into the arena. In the blog post I wrote about that, there's like a lot of text on how to actually place the bots, because you've got a specific amount of space, you have a specific amount of bot size, and it really depends on a lot of stuff. For example, if you've got two bots in the binary and they just want to override each other, it really depends on like which bot is the first, which is to be executed. Are they swapped? So if you swap the both bots, do they actually get the same result, and so on. So there's a lot you can play around with there, and yeah, that's what I'd suggest you all do now. Just get out your laptops, just clone this repo and play around with all of that, because, well, that's how you actually learn this. And if you are totally interested, like people, for example, at CCC Camp started just sitting there for, I think, like 15 hours or so. They didn't want to stop and built like crazy stuff, for example, new algorithms for actually placing the bots so it gets like a bit fairer, or some guy started building like a genetic algorithm where he started having fully automated battles between bots, which then got mutated and everything in order to actually build the best bots, which win the most rounds. So that is actually one of the things I'd recommend for all of you. Just, well, play around with it. And the last thing is, there are strategies for single bots to literally just win in the first round, because there are like crazy x86 instructions or so which allow you to override like a lot of memory at the same time and then just override everything, because the end condition of all of this is the end. Where is it defined here? So we have to define like an end condition, because as every game at some point it has to end, and the end condition in this game here is literally see if your bot can actually execute something, or you as a bot can't actually win, you can only make the others lose. So what's also possible is that if you are a bot in an arena with like 5 other bots, you'd have to have every single other bot just lose in order for you to win. And in order to do this, there are so-called traps in Radar, defined here. So what I'm doing here is defining an easel to-do or trap, and if that trap is hit, the variable the end is set to 1. So what we're actually doing in the end for every bot is checking if the end has been set to 1 for that bot, and then yeah, the bot has lost. And yeah, you can, for example, start setting like different values to 1, define new end conditions, define that the initial storage in which the bots are loaded into has been defined to be, for example, 0xFF or so. Like, there's a lot to play around with, and yeah, just do that. And with that, I'd say, I've got this slide here, which I just let you open. If you've got anything with that, you can literally read the blog post, because everything is written down there in a lot more detail, or like a bit more detail. So for you to actually just Like go into there, understand what is going on, and otherwise just ask me. And yeah, that's pretty much the talking part of all of this, so I won't be talking all too much. I'm going to help you now with all of that. So if you've got problems or so, raise your arms, just build small groups, play against each other, try to build like amazing bots. There are 2 bots in there which per default just go backwards and just start overwriting random memory. It isn't efficient, but it's a start. Start tinkering around with all of that. Then you'll get to a point where you'll realize, oh, okay, I'm starting to understand what is happening. Yeah. Okay. Has anybody actually used Radar before? Just out of interest. Oh, I'm seeing hands. That is great. So yeah, if you've used Radar before, you can also help the people left and right of you because, to be honest, at the beginning it's quite intimidating or quite weird because you've literally got no idea what to enter. And otherwise, yeah, open the code. And I know it sounds weird just telling people to read the code, but literally that's the easy part of all of this because, in my opinion, like the code is written in order to be actually read, not like the actual implementation, which, well, you can start reading into, but you probably understand nothing because, like, it's just a giant blob of mess, in my opinion. Yeah. Okay, I'm seeing people tipping on their laptops here and there. So, yeah, if you need help, raise your arms, and I'll just be going around and just helping you all. Yeah.
Any questions?
By the way, there might be a big r2wars battle at CCC camp. Not at CCC camp, at Congress, if it happens. Because, yeah, like, I've held this workshop now a few times, and there are always people who actually get, like, really hooked with that. There might be some here. Okay. Yeah. Yep. I think I'll just give you some time, like. Anybody got it up and running yet? Has it worked for anyone? I'm seeing a few hands. That's kind of pretty. And for those where it's working, are you actually seeing the bug that the bots aren't loaded correctly? For example, if I just load this here, I've got, okay, that's a bit fast. Let's say 3 seconds. Here, the instruction pointer just jumped up here, and there's literally no bot here. And what we can do with that is, we'll just make this bigger. 2. x86. Bots warrior 1. So this is actually how a bot is just looking in its raw form, and Resin 2 also has the option to actually disassemble all of that. So if you have your bot here and look into this bot, this is how you'd probably just write it in a small file. But you can also just assemble it and then disassemble it. And I'll have to tell it which architecture that is. And isn't that the disassemble command? Oh, come on. I also wrote this blog post in order for me to actually not forget how this all works, because turns out it's a lot. And yeah, I don't do this like so regularly. But yeah, this is actually how it's all supposed to work. So you can assemble your bot with Resin 2, which is just like this normal radar command. Then you can actually disassemble the bot and look into like what it actually built. And there might be things that you want to optimize. For example, the size of the bot, if the limitation is very, well, small. But you could also try like just giving it infinite amount of space and well, trying like really big bots. Like there's a lot to try out with all of this, and I think that's kind of part of the fun. What you could also do is switch it up all the time and just allow polyglots or so. So yeah, you might want to prepare yourself if you want to play at Congress, because there are a lot of fun options you can come up with in order to build the best bots. Yeah. By the way, this is just the blog post where everything is written down, so all these small commands or so you can read up here are written like a lot of descriptions on how this works, and for example how you can actually like in Radar load the bot and then execute it in order to debug it a bit. They've got this funny notation for everything in order to actually see where the registers are, where they are pointing to, and how to debug that. Yeah. So, yeah.